we can name them. Say I'm writing P, Q, R, S, right? Mind it, your PQ is L, and that is your same as RS, and your PS is B, and it is same as your QR, correct? Okay. So now, if the magnetic field in this area is from left to right, everywhere the magnetic field is from left to right, right? So we'll be seeing that everywhere in that this is uniform. So we'll be seeing, okay, here it is B is towards the right, here towards right, here on this segment it is working towards the right, same B, here also towards the right. So all the four side of that rectangle, we are seeing how the magnetic field is acting, right? Here it is making an angle of theta. This angle is your theta. Same angle here, theta, correct? Now we'll try to understand the forces acting on this coil if there is a current flowing through that. Say the current is flowing in the direction like this, right? This is the current flowing in the loop. So the moment the current is flowing and magnetic field is there everywhere from left to right, uniform, then you will find that there will be torque acting on the loop, and hence the loop will start moving. The coil will start moving. Fine. Now, the forces acting on this current carrying conductor, we know very well. Single conductor, if you take it, the force acting on the current carrying conductor kept in a magnetic field, what it should be. If I am taking the side SP, can you assess the direction of the force acting on the side SP? Let us start from that. Yes. Which direction it will act? Just think over it and let me know, any one of you. IL cross B, correct? So IL and B, you will have to keep in your left palm, right? And then do your job. IL to B.
Towards right, sir.
Towards right, in the direction of B.
Yes,
One
sir.
thumb rule you can make it. One thumb rule you can make it. That magnetic force is always perpendicular to both IL and B. So how it can be in the direction of B? Towards the left or towards the right, I am telling it. You are wrong. So think otherwise. It will be either upward, vertically upward, or downward, because it has to be perpendicular to both IL and B. Am I right? IL is from S to P, B is towards the right. So it will be perpendicular to both of them, right? You can think of, as usually we used to take, this is your x-axis, this is your y-axis, and this is your z-axis, correct? Your B is in which direction? X direction, correct? B is always in the X direction in our case. Okay, right? Now, IL. See, it is B and IL both are in the horizontal plane, right? B and IL both are in the horizontal plane, and this fellow is making angle of theta. So somewhere with the B in the horizontal plane, I can think of this line SP. Current direction is this is my current, and mind it, both IL and B are in horizontal plane. So now keep your left palm horizontally. Just do that along with me. Left palm horizontally. Think of your IL and B in that. So if I bring my right hand, IL to B, right? So if I rotate, I have to rotate anti-clockwise, yes or no? Anti-clockwise means bottle cap will be open, the screw will be open. So advancement of the screw gives the direction of the force. So tell me in which direction your force is acting on the SP. Yeah, tell me, any one of you. Give me idea. Tell me, like you told me, Ishan, that it should be towards the right. I told you why it cannot be. And then I told you that only two possibility. Either
I
it will
think
be upward or downward.
upwards.
Yeah, IL cross B, if you rotate, it will be opened up. The screw will be opened up. So opened up means advancement will be in upward directions. So that is the direction of the force, yes or no? Got
Yes, sir.
it? Clear? Right. Now come to your QR. Can you tell me which direction the force will act on the similar line? QR, that is your IL and B are in horizontal plane here for that also, right? This we had taken for SP. Similarly for QR, the same thing. IL and B are in horizontal plane. It will be.
Downwards.
It will be.
Downwards.
Yes, you are right. It will be downward. If you rotate your right hand fingers from first vector to the second vector, that is IL to B, you'll have to rotate clockwise. From top, if I'm doing, I have to rotate clockwise, so downward. So F acting downward, right? Similarly, I come to PQ. Can you tell me? Now this time, XYZ axis you always keep in your mind, PQ. In which direction PQ is? Z,
Towards
correct? Vertical. And B is, this time B is in the X direction. So now you have to keep your left palm like this in the vertical plane, XZ plane. Am I right? This way only. And then right hand fingers I'll bring here and rotate it from first vector to the second vector. First vector is downward. Yes or no? Second case, your first vector is downward. If it is downward, then if current is like that, then yes, IL cross B will be, if I rotate anti-clockwise. Anti-clockwise means screw will open up. This one is the vertical plane, XZ plane, because I is there in the Z axis, B is there in the X axis, the XZ plane. If it is that XZ plane, your vertical wall in front of you, and if you rotate your fingers from first vector to the second vector, you have to rotate anti-clockwise. Am I right? It means that a screw will come out of it, means advancement will be towards you. Towards you means along the y-axis, but away from that, right? So your force direction here, it will be towards you. That will be the force here acting. So your force here will be towards you, so along the y-axis, but it is away. So it will be your F here acting in that direction. Got it up to that? All are vector quantity only. Now see that at this point, RS, yes, RS, this direction, IL, Z direction, positive Z direction, B, X direction. So you are dealing with XZ plane, means vertical front wall. This time you have to rotate clockwise or anti-clockwise, tell me.
anti.
No, IL is vertically upward. So if I'm keeping my hands like this, bring your right hand fingers Upward is the IL, right side is your, on your right, it is your B. So from first vector to second vector, if I rotate, I have to tighten this screw. So it will be inward. So in the y direction, this is my y direction. So this is there. All the four side F, we got it. Now you check it. I can name them. Rather, I can say this is my F1, F2, F3, F4. Name them. Now you can check it. F3 and F4, they are collinear along the same line, yes or no? They are collinear along the same line. And they are equal also because your IL is same, B is same. So ILB sine theta. Here the angle is, this is your sine 90 minus theta, but sine 90 minus theta is sine theta only. So F4 will be same. F3 will be same as F3 and they will be cancel each other because they are collinear along the same line. Whereas F1 and F3, if you take it, okay, here the length is same. PQ is your L. That is same for both PQ and RS. So again, F1 and F3, if I am taking, they will be IL. So I is same, L is same, right? And IL B, that's it. Because here angle between B and I is your 90 degree. Right? We had seen for the side PQ and RS, angle is 90 degree. Yes or no? Clear up to that? Okay. Yes or no? Tell me.
Yes, sir.
Fine. So now let us write the key points, what we have discussed. We had seen that your F3 is, what is that? I into L is your B into capital B. So ILB by formula IL cross B, here it is IB cross B, and then IB sine theta, the magnitude wise. And your F4 will be, check it, IB again, capital B, and then sine 180 degree minus theta, right? That angle will be 180 degree minus theta. That is your sine theta only. So I'll be having IB sine theta only. So they are equal, right? We can say that F3 and F4 are equal and equal, collinear, and opposite, right? So equal and opposite and collinear. So I can write like this: equal, collinear, and opposite. So, and so they will cancel. They will cancel each other. So you are left with now F1 and F2 in the figure, correct? No, F1 and F3. Now, if you see that figure carefully, are they collinear? Tell me, are they collinear? No.
No,
They are
sir.
acting along. No, they are not in collinear, right? They are not in collinear. Why so? See, if I extend it back, this is along the y-axis. And if I join this from this middle point of this to middle point of this, I'll be joining like that. And if I draw this line further extend it, wherever they are meeting, that is, they are making 90 degree over there because that is in x-axis and this fellow in the y-axis. So angle between them is 90 degree. So they are making this here. They are making this as a right angle triangle. Mind it. I elaborate it. This is my 90-degree, right? In the XY plane I'm talking about, horizontal plane I'm talking about. Okay, this is your B, that, right? That width of that is B. And then this is your line of action. This is the distance between the line of action of the two forces. One of the force minded along the y-axis is here. Other one along the y-axis is here. So the distance between them is what? This is my distance. How we can find this is 90-degree, right? And then we had seen that you are having angle between the B and the x-axis, that is your theta. This angle is your theta, correct? So the distance, perpendicular distance between your F1 and F3 will be your B cos theta. Towards the theta is cos, away from theta is, other one is your sine. So I'm interested in cos. So this fellow I'm getting as B cos theta. So now this will give you the torque. That will give you the rotational effect, right? Got it? Suppose this B, whatever I'm taking, suppose I'm giving by this pen, right? And then I'm applying, somebody is pulling on this side and other fellow is pulling on this side, is going to rotate. Immediately is going to rotate. Same thing is happening here. So in this case, we can write points, we can write about F1 and F3. They are not collinear. So I can have my, we can write the perpendicular distance, the perpendicular distance between F1 and F3 is your B cos theta. In the figure we can understand, right? So F1 and F2, they are forming the torque. Therefore, we can write the torque will be equal to either force into perpendicular distance, right? Torque is your either force into perpendicular distance. I am writing in short, perpendicular distance. What is either force? Anyone I can take, F1 or F2, right? F1 into perpendicular distance is B cos theta, right? So this is the torque finally we are going to have. Clear? Got it? So now we can understand what is my F1. F1 is ILB, correct? Here in this case, we can understand my F1 is I into L. L is PQ, the length PQ is L. So IL and capital B. Angle between IL and B is your 90 degrees, so sine 90. I can use that F1 to get my job done here. So your torque, I can take that torque is equal to, in place of F1, I can write ILB and then a small b cos theta, right? So further, if you take, I can write my torque is equal to, see that ILB, a small b I can keep on the left, ILB, b cos theta. So finally we can write here, therefore your torque is equal to IL small b, capital B cos theta. Now L into B is, yes, L into B is the area of the loop. You can see this is the rectangle. The length of the rectangle is your L and B is the width. So L into B will be the area of the loop. So well, I can write my torque is equal to I into A, right? I can write this as I into A into B cos theta. Got it? I into L into B cos theta, correct? So this is the expression we are getting for the torque, right? Clear? IAB cos theta. Mind it, theta is the angle between the plane of the loop. Again, if you see the figure, theta is the angle between
Plane of the
plane
loop.
of the loop and B. You can check this, right? Clear?